Most of you probably have heard of the number pi. There's Pi Day and a whole thing around it. Pi is very popular. Most of you probably know that pi is a number that goes on and on. Some of you maybe can even recite the first few numbers of pi. Some of you may have never thought about this, but pi is a number. You can multiply it in a calculator and get a number back. Try it out. Put in 3 times pi into a calculator. You will get a number back. Pi is not a variable. It is a number that just goes on forever. Let's talk about pi's lesser-known friend, e, also called Euler's number. You see e a lot in math, usually as a function like this. And e is also, like pi, just a number that also goes on forever and ever. The value of pi is 3.1415, etc., and goes on. And the value of e is kind of close. 2.718, and then that also continues and goes on. So why do we always see Euler's number in math, biology, finance? Well, at this point, let's just say it's because it has some cool properties, and so it is great for modeling things that grow fast. We talked about 3 to the x in another video. E to the x is similar. Its base is just 2.7 to the x. Well, 2.718, blah, blah, blah. But it does nice things, like its growth rate is equal to itself. When you take calculus and do derivatives, you will see that. So maybe if that was all too complicated, think of it this way. E has some nice properties for modeling things in real life. That's why we use it. So in this video, I'm going to go over the graphs of exponential functions. And since e to the x is so popular, I'm going to use that as my example. So here we have the graph of e to the x. Let's talk about some important information this graph gives. So we're going to go over what happens when moving from left to right on the graph. So let's start with negative x values. We are going to put in -4, so we have e to the -4. Then e to the -3 and so on until we get to x as 0. When x is negative, e to the x is almost 0. It starts to approach 1 as you move right. When x gets to 0, you can see that y is 1, meaning e to the 0 is 1. Now we are going to start moving to the right, so x is now positive. So we are inputting positive numbers into e to the x. E to the 1, e to the 2, and so on. We can see now that the y value is starting to get larger. And as we keep moving right, it just kind of shoots off the graph. It gets so large. So one thing we can say about the graph as it moves from left to right is that it increases. The values get larger as x gets larger. What else is interesting about this graph? Let's look over at the left side of the graph where x is negative. What does it look like the y values are over on the left side where x is negative? This whole area looks like y is 0, doesn't it? Let's put a tracker on there and see what the values actually are. On the left here, we start at x equals -100. So when x is -100, e to the -100 is this number with the e minus 44. I don't know if you remember, but that means that this is actually 0.0000 with 44 zeros, then 372, and so on. So it's practically 0, but it's not exactly 0. Let's move right to where x is -50. And here e to the -50 is 0.00022 times, then 192, and so on. So again, not exactly 0, but so close. Now if we look over when x is -2. So now we are getting closer to positive x values. Now e to the -2 is 0.13533. So where we are moving away from 0 now, which you can see on the graph. So that is another interesting property of exponential functions. As x is large negative, so like negative 100, negative 1000, the values are approaching zero, but never actually are zero. They're just very close. The next interesting property about exponential functions is what happens when x equals 0. If we come over to when x is 0, we see that the y value, or e to the 0, is 1. All of these properties are the same for any exponential function. 3 to the x, 2 to the x, 10 to the x, etc. So for any exponential function, this is true. Plug in 0, you will get 1. It doesn't matter if it's e or 2 or 5 or whatever. Next, we will look at the interesting part of the right side of the graph. Take a look at x equals 1. The y value is just 2.718. That's e to the 1. Then if we just go a little bit over to x equals 3, we have that e to the 3 is 20.08. And then moving to x equals 5, y jumps a lot to off this graph at almost 150. So what we are seeing is that it grows so fast, it quickly starts to go off the graph. That is the idea of the exponential function. It grows fast, and we will see later in another video, it can also decay quickly as well. So those are some of the important things to look at when you are looking at the graph of an exponential function. All of these are true with any positive base greater than 1, such as 2 to the x, 5 to the x, 10 to the x, e to the x. Hopefully these graphs help you better understand e and other exponential functions.